Sweet. All right. Welcome. What I want to do is I'm doing another live stream tonight, and what I'm about to do is go over my analytic trigonometry quiz that I gave to my students. And on this quiz, we're going to go through solving, verifying, and simplifying identities. And then once we're kind of through with the quiz, it's probably going to take me a little bit longer though. But what I will be more than happy to do is kind of answer any of your questions that you guys have coming up. So thank you guys for joining. George, Esmeralda, American Pastor, good to see you guys. I'm going to go ahead and change over to this quiz. So those of you guys that are joining in, you can kind of see what kind of problems I'm going to be covering. You can see here we're dealing with, solving. So the first 4 questions is going to be solving. And then I'm going to get into simplifying trigonometric expressions. And then last but not least, I have 2 problems that we're going to be dealing with verifying trigonometric identities. So we are wrapping up our unit right now. This is for my pre-calculus class. We are wrapping up our unit in analytic trigonometry. I'm just kind of finishing up going through the sum and difference, double angle, and half angle identities. And then I'm going to give my students a test. And then we're going to kind of move on to law sines, law cosines, and, kind of look into wrapping up the year. So as you guys are kind of joining in, if you guys have some questions that you want me to kind of answer, I will try to see what I can answer at the end. I'm not going to take too many breaks except for just to kind of say hello and kind of see if there's any questions specifically is what I'm working on. But once I kind of get started with the quiz, I'm just going to kind of like move through it. So those of my students or anybody else that's watching through the quiz is not really getting distracted by the live stream and the comments. However, once I am done, I'll be more than happy to kind of answer some questions and also to interact with you guys. There are a couple of typos that I made on this quiz, but I'll kind of address those as they kind of get in. So, all right, as you guys are kind of joining in, I'm just going to go ahead and get started. And good to see you guys. George, looks like you have a test tomorrow. Well, good luck, bud. Just keep on working hard and studying, and I'm gonna do my best. Hopefully, maybe you have something that's similar. There we go. All right. So the first problem that we're working on is find all the solutions between 0 and 2 pi. And this one is saying cosine of theta is equal to negative square root of 3 over 2. So basically what we're doing is we're looking for on the unit circle, what values between 0 and 2 pi where cosine of theta is equal to negative square root of 3 over 2. Well, the main important thing I think we need to understand, at least for solving this problem, is, when is cosine equal to negative square root of 3 over 2? Now, the nice thing is about this condition is between 0 and 2 pi, that's basically, the path here of the unit circle, right? There's between 0 and 2 pi. So forget about the negative for a second. Let's just look at when is cosine equal to positive square root of 3 over 2? Well, that's going to be right there, which is the angle pi over 6. And that coordinate point, you can see is square root of 3 over 2, comma, 1/2. So if we're looking for when cosine is going to be negative, it's going to have the same reference angle, pi over 6, but we know that cosine's negative in the second and the third quadrant. So it's basically going to be a reflection across the y-axis and then also a reflection about the origin. So it's going to be these 2 angles which have the same reference angle of pi over 6. And if we know that half of a circle is represented as pi in terms of radians, then this is pi over 6 short, which is going to be, I'm going to use set notation here. So pi over 6 short of pi is going to be 5 pi over 6. Pi over 6 short of pi, right, is 5 pi over 6. And then pi over 6 over pi was going to be giving me an angle of 7 pi over 6. Now, I did forget to tell you guys, I was kind of late last week live streaming because I was kind of feeling lethargic at night and I just wasn't really able to get as much work. Once I got home, I was just really tired. And then also my hands were really cramping. So I'm going to kind of see how this, kind of works for the rest of this live stream. But my hands are kind of a little bit slow as I'm writing and it's just been a little bit hard work for me to do. So I'm going to do my best. But so far, I'm feeling all right. All right, so this next one is 2 sine squared of theta minus 1. Now, in the previous example, we didn't really have to do anything. Cosine of theta was already isolated. And, we basically just found the values of theta that made the equation true for 0 to 2 pi. In this example, though, before we try to find the values that make this equation or identity true, we basically want to isolate the sine of theta. So the first thing we're going to do is, well, actually, I'm going to save some time. I'm going to add 1 and divide by 2. So therefore, I'm left with sine squared of theta is equal to positive 1/2. Now I need to undo the square root, and one thing that I have been drilling with my students as far as making sure that they understand, when you introduce that square root, make sure you're including that plus or minus, because when you forget that plus or minus, you're leaving half of your solutions on the table. So I take the square root of both sides. Now, when I take the square root of a fraction, I can take the square root of the numerator and the denominator separately. The square root of 1 is just 1, but then I'm left with, let's put this over here, I got a little bit more work. So sine of theta equals plus or minus 1 over the square root of 2. Now, as far as looking for the points on the unit circle where 1 over square root of 2, it might not be as obvious, so therefore rationalizing the denominator, multiplying by the square root of 2 over 2, is going to help us out, at least identify, that's going to be plus or minus square root of 2 over, and then square root of 2 times square root of 2 is going to be 2. So when we go back and look at the unit circle, we're saying, all right, when is sine equal to plus or minus the square root of 2 over 2? Well, if we just kind of look at the first quadrant, we know that angle is going to be pi over 4, right? And that's the point where it's square root of 2 over 2, comma, square root of 2 over 2. So if we're looking for plus or minus, that's going to be all the other angles that have the same reference angle, basically reflecting over the x, the y, and the origin. So again, kind of using our idea here of, my arm hurts. Kind of using that idea of, halfway is pi, if we're at, let's use set notation here. So we're at pi over 4 is the one angle that makes the equation true. Then we're pi over 4 short of pi, which is 3 pi over 4. We're pi over 4 over pi, which is going to be 5 pi over 4. And then we're pi over 4 short of 2 pi, which is going to be at 7 pi over 4. Now, one of the questions that that a lot of students bring up, especially when we're dealing with inverses, they say, well, why don't we do negative? Why don't we do negative pi over 4, or negative 2 pi or 3 pi over 4? And the reason why is because any negative angles are not within our restriction here, because we're looking for all the solutions between 0 and 2 pi. That means all the angles there are going to have to be positive. All right, so let's go and move into the next one here, which is tangent of theta times secant of theta minus 2. Now, I changed this for my students when they were doing the problem. I'm going to try zooming in one more time, zoom in, not zoom out. I'm going to see if this kind of helps me with my writing a little bit. So when they were doing this problem, I actually changed this to give me a 2. So I wrote that as 2 tangent of 2 theta. Now, the difference here is not going to really be anything until the very, very end, but I wanted to kind of explain this one to you and as also to my students and see how that changes. Also here in this case, we have secant of theta minus 2. Now, this is really important to really kind of rewrite this to really understand. Remember, secant is the reciprocal of cosine. So I can really rewrite this as tangent here of 2 theta. And then times, I can rewrite this as cosine of theta, and then just use the reciprocal here, which would be minus 1/2 equals 0. Because remember, cosecant and secant are reciprocals of each other, so you can just basically go ahead and reciprocate. Now, notice I have the product of two expressions equal to 0, and what that means is I can now apply the zero product property. I'm going to kind of zoom back out and kind of look at this. So therefore, I can now write this as tangent of 2 theta is equal to 0. You know what, let's try even going a little bit more. And then cosine of theta is equal to 1/2. Hopefully that's not too skinny for you guys. You guys can still see it. So now let's go ahead and take a look at the angles. Now forget about 2 theta for a second. Let's just figure out what angles when tangent is equal to 0. Well, remember, tangent is the y-coordinate over the x-coordinate, right? So we're looking for when is the y-coordinate over the x-coordinate going to equal 0? Well, the only time that's going to equal 0 is when the y-coordinate is going to be 0, because it can't be when the x-coordinate is equal to 0. So if we look at the unit circle here, what we're doing is we're looking for when is the y-coordinate going to be 0 and the x-coordinate going to be 1 or -1. It doesn't really matter as long as it's 0. Well, we have that here, 1, 0, and we have that over here, -1, 0. So we know if we don't move anywhere, that's going to be pi. And if we go halfway around the circle here, if we don't go anywhere, that's 0 as an angle. If we go for halfway around here, that's going to be pi. And then if we go all the way around the circle, that's going to be 2 pi. So you can see here we kind of got 3 angles. But again, going back to our restriction here, our angles need to be between 0 and 2 pi. Well, 0 is included, but 2 pi is not included. So we're going to use 0 as this angle representing this point, but not 2 pi, since 2 pi is not included. All right, so therefore I have my angle as 2 theta is equal to 0. And then also we have 2 theta is equal to pi. Okay, so those are going to be our 2 angles, but we're not done with the 2. What we need to do now is we obviously need to solve for theta. So I'm going to divide by 2. And obviously just there we'll have theta equals 0. And when I divide by 2 here, I get theta equals pi halves. Okay? So right now we have two solutions. We have 0 and pi, but they got divided by 2 because we were looking for the half, or we were looking at that double angle, so we had to divide by 2. Now, we got to see, are there any more solutions? And this is where it kind of comes really important. You got to look at what's happening with the equation. When we had y equals tangent of x, then what we knew is the period was pi because the graph repeated every pi. Every single time the pi, the whole graph and all the points, all the asymptotes, every single thing repeated. Now again, remember these solutions, that's basically where the graph is crossing the x-axis. So you can see within this initial period, my graph is crossing between 0 and at pi halves. And it's going to repeat every pi. Well, if the equation was just y equals tangent of x, then I'd try to see if I could add pi to it, and that would be my other solutions. But pi is not my period for this equation. My period now is going to be pi halves because 2 theta. Because again, remember, period for tangent is pi divided by b, which in this case, my b is 2. So what I want to do is I need to now see if I can add pi halves to each of these angles. Now, I don't need to add it to 0 because 0 plus pi halves is just pi halves. So I'm just going to add pi halves n times, meaning I can add it as many times as I can as long as it fits within my constraints. I'll come back to writing all the answers here in just a second. Let's go ahead and cover up what cosine of theta is for 1/2. So cosine is equal to positive 1/2. Well, that's up here, which is that angle, which is pi over 3. And then cosine has to be positive in the first and the fourth quadrant. That means it has to have the same reference angle down here. I, again, don't want to use the negative angle. I got to use this angle all the way around here. And so then I got to think again to myself, well, if here's pi over 3, then that means this is pi over 3. So all the way around would be 2 pi, but I'm pi over 3 short. All the way around is 6 pi over 3. So if I'm pi over 3 short, that means I'm at 5 pi over 3. All right, so let's go and write down all these solutions. So I have my first solution, which is pi over 3. My next solution, which would be 5 pi over 3, and that covers everything from cosine. Now let's go to the tangent. We found 0, and we found pi halves. Now, I said, though, I can add pi halves n because that's my new period. So if I add pi halves to pi halves, I'm going to be left with pi. If I add pi halves again, I'm going to be left with 3 pi halves. And if I add pi halves again, I'm going to be left with 2 pi. But remember, 2 pi is not included in our solution set, so that's going to be all of my answers. And again, you could rewrite them in ordered form if you want to. So if you guys are just joining in, welcome. What I am doing is I'm just kind of working through a quiz that I recently gave to my students. So this quiz is, this quiz is over Analytic Trigonometry. It is covering everything from solving to simplifying to verifying, and I'm just going to work through this kind of as quickly as I can, and then for those of you that are joining late, I will be answering any kind of questions you guys are working on if you're taking a test or got homework, whatever else. I'll try to do my best to go ahead and help you out. So let's go ahead and do this last one here. Now this next one kind of gets a lot of students because it's dealing with factoring. So I'm kind of got a little short on my work here. So what I usually like to do though, when I'm trying to do something factored, in this format, I usually like to think of these as x's instead of signs. So I'd rewrite this as 2x squared minus 3x plus 1 equals 0. What that allows me to do is say, all right, I can factor this, or at least I've been taught in Algebra 2 how to factor this. And I can basically break this down into, 2x times something else times x, And, you could set equal to 0, I guess. But basically what we're doing is we're saying what two numbers multiply to give me 1, and then when they multiplied with that 2 and the x, are going to add to give me negative 3x. Well, there's only so many numbers that multiply to give you positive 1, right? It's positive 1, and negative 1, and negative 1. So since my middle term is negative, I can kind of quickly identify that these two numbers both need to be in negative 1. And I'm not going to go back and check my work because I know that's the answer. But if you're kind of confused, or if you're always, hesitant if you got it right, just go back and FOIL it through. But the nice thing about doing this is it's easy to factor with x's, because now I can go back to my problem and say, all right, now all I'm going to do is just replace the x's with the sine of thetas. So it's kind of like using a little substitution there. Well, it is using substitution, just to kind of help you with the factoring. Sine of theta minus 1. Okay, so now once we have that, now we can go ahead and apply the zero product property. We can set these both equal to 0 and then solve or isolate the sine of theta. So to save myself a little bit of time here, I'm just going to go ahead and do that, and I'll get sine of theta is equal to positive 1/2. And over here, I'd get sine of theta is equal to 1. Now, I've kind of showed the unit circle here quite a bit of times, but let's look over here. If you remember back up this solution, you can see that sine, the y-coordinate, is equal to positive 1/2 at the angle pi over 6. So if I'm looking for what other angle is sine going to be positive 1/2, well, that's also going to be, that angle right there, which is what we found out to be 5 pi over 6. So sine of theta is equal to 1/2 at my angles, pi over 6. Pi over 6, yep. 5 pi over 6. And sine is equal to 1. Well, when is sine equal to 1? Where was that other triangle that I created? Or not triangle, but unicircle. Oh, okay, here. So when we're looking at this unicircle, you can see that the x-coordinates is 1. We're looking for when the sine coordinate is 1. Well, that's going to occur up here, which would be 0, 1. And then down here, though, would be 0, negative 1. So we're obviously looking for when sine is positive. That's going to be that, which is half a pi, which you could say is pi halves, or the same thing as 90 degrees. So there you go, ladies and gentlemen. So that is your quick little overview on solving. Now what we're going to do is go ahead and get started with simplifying. But before I kind of get into simplifying, let's go and check, see who's in the chat, see who's joining us, and kind of give you guys some shout outs, see what you guys are up to. So hey, Elizabeth, hey, June, hey, Sharon. How are you guys doing tonight? Glad you guys could join. And yes, Elizabeth, I will be talking about this unit circle here. And well, I'm not going to get deep into the unit circle because I've been talking a lot about unit circle. June asks, can I also verify trig identities by factoring? You absolutely can. I don't have any examples, I believe, in this quiz, but if you have one after I'm done with this quiz, I'll be more than happy to go over it. And Caitlin says, you're so awesome, not your class, but literally just looked over the exact same things for my test. Awesome. Well, that's what I kind of like about at least the pre-calculus. This is obviously I've been going live primarily for students that are taking pre-calculus. But, one of the things I want to do is branch out for students that are taking Algebra 1, Geometry, Calculus, other classes to kind of help them out. But for right now, I'm kind of getting my feet wet with this whole live stream thing as far as, just working through my pre-calculus curriculum, because that is at least the one curriculum that I've created the most amount of content for. So something I definitely want to continue, though, for next year and for other future courses. Yes, Hope. I'm looking into doing some calculus. I do have majority of my videos right now that I'm posting online are in the calculus curriculum, but just not so much as far as the live streams just yet. All right, so let's kind of get into simplifying the expression of a single trigonometric function or number. So basically what we're going to be doing here is simplifying this trigonometric function based down to a single trigonometric function or a number. So in this first one, we basically just need to know our even and odd identities as well as our cofunction identities. So the first thing I'm going to do is I'm just going to rewrite everything in terms of those basic identities. So the sine of negative x is, using the odd identity, is going to be just the sine of x. The secant of negative x is equal to the secant of x. And the tangent of pi halves minus x is equal to cotangent of x. All right, so now I kind of rewrote them without using this, the negative angles and the cofunction identities. Now to kind of simplify this, I want to look into maybe just writing everything in terms of sines and cosines and kind of seeing what divides out. So that would be my next step. So I'll divide that sine of x times 1 over cosine of x times cosine of x over sine of x. And what you can see here is by applying this division property, the cosine of x's divide out and the sine of x's divide out. They're over there. So therefore my sine of x's also are going to divide out, leave me with a negative 1 over 1, which is just negative 1. So that is my simplified. You can see the simplified expression now is a number, just like I said, to leave it into. For this next one is 1 plus cotangent squared of x divided by tangent squared of x, or tangent squared of x plus 1. And that was a typo on my part. Sorry about that. So when working on this problem, basically, whenever I see squareds, I'm always looking at the Pythagorean identities, like what Pythagorean identity here could be applied. And 1 plus cotangent squared of x, that's really, as using your Pythagorean identity, that's equal to cosecant squared. So I can just rewrite that as cosecant squared of x. And tangent squared of x plus 1 is equal to secant squared of x. Okay, so now again, remember the directions said to write your trigonometric function in terms of one trigonometric function number. So here I have 2 trigonometric functions, and I want to get that down to 1. So again, kind of like what I did over here, let's kind of rewrite everything in terms of sines and cosines and then kind of see how we could, simplify that. So cosecant squared of x is really just 1 over sine squared of x. That's using the reciprocal identity. And secant squared of x is 1 over cosine squared of x. So now I basically have a fraction divided by another fraction. If I want to get rid of this fraction, I can multiply by the reciprocal and do that on the top and the bottom. Therefore, that all goes to 1, and I'm just left with cosine squared of x over sine squared of x. Well, cosine squared of x over sine squared of x is going to equal cotangent squared of x. And now I have rewritten my expression as one single trigonometric function. All right, the next one looks like it's subtracting. Well, at least it's asking us, it's saying, hey, subtract. So it's like, all right, well, if I'm going to subtract, that means if it's asking me to subtract, subtraction is probably a good idea to get started with. But to go ahead and subtract here, what I basically need to do is you got to make sure you have common denominators. So I look at sine and cosine and say, all right, what's the common denominator here of sine and cosine? Well, it's just going to be their product. Just like if it was 1/3 and 1/4, the easy way to find the common denominator here is just to multiply. That's not always the case, but in this case, it is going to be the fastest way to find the common denominator. It's just the product. So sometimes I'll write that up above. I'll say that, the LCD here is sine of x, cosine of x. So therefore, I need to get cosine of x, sine of x as my denominator. So on this side, I need to multiply by the sine of x on the top and bottom. And over here, I need to multiply by the cosine of x on the top and bottom. Now, I notice cosine of x times secant of x, that's reciprocal to being multiplied by each other. So that's going to give me 1. And then minus, let's just write it like this. 1 over cosine of x, sine of x, minus sine squared of x, right? Because sine of x squared times sine of x squared is sine squared of x, all over cosine of x, sine of x. Now you see that they have common denominators, so I can combine them, but you keep the denominator the same, and obviously you just apply the operation to the numerator. Well, there's nothing much we can look at right now of saying I can't really combine 1 minus sine squared of x. However, if you think about 1 minus sine squared of x, again, looking at your Pythagorean identities, what you would realize is, 1 minus sine squared of x, that's equal to cosine squared. So cosine squared of x over cosine of x, sine of x. Now, you could break up cosine squared of x as cosine times cosine, or therefore you could see that the cosine would divide out, or sometimes, I just kind of cross out the power there. And you can see now we're just left with cosine of x over sine of x, which is just equal to cotangent of x. Okay, so very similar to our last one. All right, so now number D. Actually, no, this is the one I was got. All right, so we're almost there. Now this one again is asking us to add. So again, guys, if it's asking us to add, let's try to add. Now we see we have denominators that are similar to each other, but they're not exactly the same. So again, we got to find our least common denominator. Well, again, this least common denominator in this case is just going to be the product of my two denominators. There's nothing really that they have in common that I can get a more simplified common denominator. So I'm just going to multiply them by each other to get my common denominator. So to get my common denominator over here, I need to multiply by 1 plus sine of x. 1 plus sine of x. And then on the left side, I'm going to multiply by 1 minus sine of x. Now, I will say, whenever you're looking at, expressions with like 1 plus, and you multiplying by the conjugate, you're looking at that difference of two squares. And, often that's going to give you a trigonometric or a Pythagorean identity. And you can see here, when I multiply this out, I'm going to get 1 minus sine squared, which is cosine squared, right? When you multiply this out, that gives you 1 minus sine squared, which again is cosine squared of x. So I'm going to go ahead and leave that as my denominator instead of, not multiplying it out. Now for this, there's really not much I can simplify. So I kind of have the intuitive sense that I'm going to want to distribute my cosine to both of these so I can kind of see how I can simplify this. So let's go ahead and do this, and I'm going to put it all over my common denominator. I'm going to kind of save some work here. Rather than rewriting the common denominators and then combining them as under one denominator, I'm just going to know that the common denominator here is 1 minus sine squared, which is the same thing as cosine squared of x. So let's go ahead and multiply this out. And again, that's not always the best idea. Sometimes it's best to like leave it factored out, but just for kind of work and time purposes, I'm going to leave that as is. So let's go ahead and multiply this, which would be cosine of x. Cosine times negative sine of x is going to be a negative cosine of x, sine of x. And then over here, we're left with a positive cosine of x. And then we have a plus cosine of x times sine of x. So that's going to give me cosine of x, sine of x. And usually what you can do is once you multiply this top and kind of see, all right, is there anything that, should I leave it non-multiplied out, or should I multiply these out and try to combine them? And I see that I don't have any one of these expressions where it's going to be like beneficial not to multiply it out. So that means I'm going to multiply my denominator, so that gives me 1 minus, actually, no, I'll just do it as like that. Let's multiply these out. 1 minus sine squared of x. Now, the reason why I'm kind of working ahead here is you can see that these are the exact same, but the one's positive, one's negative, so those are going to add to 0. And then here you have two of the exact same cosines. So just like, So just like x plus x is 2x, cosine of x plus cosine of x is 2 cosine of x. So that means in my numerator, I'm left with 2 cosine of x. My denominator, this can be rewritten as cosine squared of x. Or again, that's, another way of writing that is 2 cosine of x over cosine of x times cosine of x. So therefore, those cosines of x divide out, and you're left with 2 over cosine of x, which can be simplified using the reciprocal identity as 2 secant of x. And there you go. So there you go, ladies and gentlemen. We are now done with simplifying. If you guys are just joining in, I only have one more little part to do. I am now going to be going over my verifying identities. And the verifying identities is basically going to be, checking or showing that one side is equal to the other side. And then once we're done with the verifying identities, I'll be answering any kind of question you guys have. So if you guys do have some questions that you want me to answer on anything that you're going over, let's see what time, 9:13. So I'll have some time to answer your questions. Hopefully I'll be able to get to them. And, but I want to kind of just wrap up this quiz here for my students, and then we'll get going onto your questions. All right, so verifying identities. Again, basically on verifying identities, we want to be able to pick a side, the side that we're going to want to simplify to make it look like the other side. So obviously in this one, I'm going to want to pick the left side. This looks like there's a little bit more work that can be applied here on the left side than compared to the right side. And, first, after you've kind of picked your side, the next step was look to apply the operations. Well, you can see here I have multiplying up in the numerator. So let's go ahead and multiply them. Now, you could go ahead and do distributive property, FOIL, whatever else you know. However, if you guys look at this and notice that this is basically, again, multiplying the difference of two squares. So it's basically going to be the first term squared minus the second term squared. Cosine squared of u all over cosine squared of u equal to tangent squared. Then I can rewrite 1 minus cosine squared of u as sine squared of u over cosine squared of u. Well, sine squared of u over cosine squared of u is just equal to tangent squared of u. Verified. So just make sure you're knowing you're applying your operation, and then also not only applying your operation, but then knowing your Pythagorean identities as well as the quotient identity. All right, so this next one was a little tricky for a lot of my for some of my students, and I kind of designed that a little bit to really test is how far are they willing to try things, not just like do one operation and get the answer, but it's like, can you start thinking out of the box? Can you start working through things? And we've practiced all of the items that are going to be on this one, but I know a lot of students just are quick to kind of give up. And there was a typo on this, which I changed for them, which would be negative cosine of x. All right, so the first thing we've got to pick a side. Now you could really pick either side. The side that I'm going to pick here is I'm just going to pick the left side. And because usually, when something's separated by addition and this side is not, I usually think it's easier to simplify the side that's with addition to combine them to try to get them as one rational term. Now, as far as adding tangent and secant, that really doesn't make too much sense to me of how I can combine them. But if I rewrite them in terms of sines and cosines, then this is sine of x over cosine of x plus 1 over cosine of x. Okay, well, that kind of seems a little bit easier to add them. They both have common denominators as fractions. So let's go ahead and combine them. And by combining them, I get sine of x plus 1 over cosine of x. Now, the problem is I've rewritten it as one rational term, but it doesn't look anything like the right-hand side. So it's kind of like, all right, now you're like, what do I do now? Well, one thing I mentioned to my students is, a lot of times when you get stuck, look to multiplying by the conjugate. So if sine of x plus 1, the conjugate would be sine of x minus 1. And we kind of did that in the problem above. We were doing this to get common denominators, but what's nice about multiplying by the conjugate is you get that Pythagorean identity. So if I multiply by the conjugate, which is sine of x minus 1, and you have to do that on the top and the bottom, what that's now going to do is that's now going to give me the trigonometric identity. So that would give me, oh, actually that doesn't. But that gives me, I hate when I have to do work over on another side. But anyways, that gives me sine squared of x minus 1 over sine of x minus 1 times cosine of x. Now, I want to get my trigonometric identity, but my trigonometric identity is 1 minus sine squared of x. And this is sine squared of x minus 1. So what I can do is I could factor out a negative in this numerator, and I'm going to kind of do some work over here because I want to keep this, he does this. So I'm going to kind of rework my problem back over here. Sorry about that. I hate when I kind of run out of space. I don't want to write a line there. All right. So if I factor out a negative, then if I factor out a negative here, what I'm left with is a negative sine squared of x plus 1 all over, then the exact same thing, sine of x minus 1 times cosine of x. Let's erase that. Okay, that equals. So you can see now, or I could rewrite this as 1 minus sine squared, either way, but you can see that that now is going to be cosine squared of x. So I now have cosine squared of x all over sine of x minus 1 over cosine of x. Well, again, kind of going back to what we've discussed earlier, now this cosine, that's really cosine of x times cosine of x, and that divide out, oops, there's that negative there, forgot about that. That's negative sine squared of x plus 1 is now going to equal negative cosine of x when you look at your Pythagorean identity. Sorry about that. So that's negative cosine of x, which you guys can see. Did I rewrite cosine, sine of x? Oh, sine of x minus 1. Factoring out the negative. Where did I go wrong here? Hold on, let me look it back on my notes here. That's sine squared of x minus 1. but that doesn't equal. Did I not write that down wrong? Uh-oh, I might have to throw out this problem. I think I wrote down the wrong problem here, because if I look at this negative, sorry, that's perfectly live stream, perfect to go ahead and notice my answer. I wrote down my answer as far as the key, but I didn't grade it for on this, so I think I might have wrote down the problem wrong. So let me kind of go through this again. Let's kind of verify our answer here. So we have cosine squared of x minus or plus sine squared of x equals 1. So if we're looking at this, that cosine squared of x is equal to 1 minus sine squared of x, right? Or you could think of that as like the negative, that if the negative would be, so if I was going to do the negative, it would be sine squared of x minus 1 equals negative cosine squared of x. All right, so when I multiply this, I get sine squared of x minus 1, which is equal to negative cosine of x. But that's equal to a negative cosine of x. No, I didn't write that down. So that's equal to negative cosine of x, which then I'd have to go ahead and multiply this, though, by a negative. Okay. Now I'm starting getting confused on my own problem. Perfect, right? And live stream doesn't give you any time to go ahead and wait. So now let's go ahead and so when I do that, so that's equal, so when I multiply that cosine squared, so that's equal to negative cosine squared of x. But I think I might have had that problem right then, because then you'd have to multiply by a negative in this case, or factor out a negative in that case, and then you'd be left with the negative cosine of x. Okay, well, either way, I'll go ahead and address it in my class, but I believe actually as it was written, I'll have to go back and check the problem where I went back and got it. So I apologize. I'm sure probably some of you guys are looking at it and be like, oh, the answer going through on just there, and that's awesome. I'll go back and look through the chat as you guys, kind of wrap it up with there. But I've been talking here for the last, 45 minutes, so I'm not going to spend too much time working on the problem. I know once I get back in class and I'll just look at the problem where I drew it and kind of see, again, kind of look at my work and see where I went to. But I do have, let's see, eight minutes. I can maybe answer some of your questions from you guys. If you guys have anything that I can maybe help to address. So let me just go ahead and check the chat here. Yeah, I know, Brian. It's like, I don't know. My brain is, I'm not too worried about it. I mean, I know it's, it gets into the, like, just the tired form of it. And I'm like, I've looked at this problem. Like I looked at my answers and I remember I looked at like the typo and I was like, oh, I figured it out. But then again, like you'll have these times where you're, doing it and you just like get this mind block, and I've kind of figured out like not to really worry too much about it. I'm just going to wait till I go to sleep, and then I can go over the problem like with a fresh brain, not after going on a live stream, and I'll be able to come around figure it out. It might make me look a little bit idiotic not being able to figure out on live stream, but I'm not really too worried about that. All right, let's go ahead and see if there's any other questions here. Jessica says, why is 0 included in the restriction but not 2 pi? Jessica, the reason why that is the case is because as you kind of go back up here, you can see that 0 is dealing with the bracket. And if you remember when we were talking about functions, 0 is included when we're dealing with the bracket, but 2 pi is not. And again, that's just the restriction. Again, we could open up this restriction to, all solutions, right? So we're just restricting the solutions between 0 and 2 pi, but we're not going to include 2 pi and we're going to include 0. Why should we not include 2 pi and not include 0? It's just really up to, how the restrictions is written. You could really write the restrictions any way we want to. This is just a little bit more of standard practice to go from 0 included to 2 pi not included, but in reality, we could really write them any way we want. All right. Anybody else have any questions? I'll be more than happy to answer them for you. Kind of seeing what else we have going on. It's as far as content and live streams going on. what I kind of plan to do here is coming up for, this week and next, as far as going over kind of homework solutions and homework content, as we're kind of getting into now these next identities. So to kind of give you an update, I will be hopefully doing another live stream either tomorrow night or Wednesday, kind of going over some indifference identities. And then I will also cover another live stream as far as going over the half angles and double angle formulas. So that's kind of what I have coming up as far as my next couple of streams. All right, guys. Well, if there are no other questions, I am just going to then cut it so I can get on to my work, because I got school tomorrow and I got to go ahead and plan and prepare. But I really do appreciate you guys joining me for the live stream. And again, look out for me next time. I'll try to do a little bit of more of a warning here for my next upcoming live streams. So therefore, you guys, if you can prepare questions and get them ready, and I'll be more than happy to help you guys out. All right. Have a good night, guys.